Well, hello everyone, and welcome to our webinar on automation, DevOps, and security. We have a lot to cover today, so I kind of want to just jump right into it. Let's see here. All right, perfect. So for our agenda today, we're going to cover the principles of DevOps in the cloud. We're also going to unpack the components of an automated environment, and we're going to explore one of our customers that had a particular challenge with operating in the cloud, how best Logicworks was able to help them achieve an immutable infrastructure and improve their security posture. And at the end, we'll just review the impact of automation on security, some of the aspects that Felipe touched on earlier. So a bit about me. I'm a certified multi-cloud solutions architect here at Logicworks with over 12 years of IT experience. I was born and raised in Jamaica, and I'm currently learning to fly a Cessna 172. Now, Logicworks is a AWS Premier Partner and Azure Expert MSP and a leader in migration and managed services for highly regulated industries. Now, we often work with customers seeking to improve their security posture through the use of automation, and we have actually created a cloud reliability platform. So let me say it again, cloud reliability platform that protects over 500 trillion financial transactions. So what we're able to do here at Logicworks is take a software-driven approach to cloud management, and we act as a force multiplier for your business by automating security, governance, and compliance for your infrastructure. Okay, so over the last year, we've seen a sharp increase in businesses leveraging the public cloud to gain a competitive advantage. And the teams responsible for managing this now cloud real estate, your cloud assets, are painfully discovering that their traditional on-prem approach to managing resources doesn't translate well to the cloud. It's becoming increasingly challenging to manage these systems, and as applications become more distributed, it becomes almost impossible to manage these systems. So the question we ask ourselves is, how do we manage constant change within our infrastructure to allow for rapid development and deployment of new application features? And the only way we can efficiently do this and effectively is through automation. When a company embraces automation, in my opinion, they innovate faster and they tend to outpace their competition. So when I'm working with customers on their cloud initiatives, I like to first understand, well, what are the business objectives? As I find that paves the way to identify more clearly their IT objectives or, well, their technical objectives. Now, typically, their objectives will fall within one of these four areas here. And for some projects, they'll encompass all four. So first is modernizing the system components and tools to enable rapid deployment of your applications while scaling those applications to meet your customer demands. Also improving the security posture of the org to prevent attacks, but also I believe it's our responsibility as IT professionals to be responsible stewards of our customer data. So we want to make sure that the data is encrypted at rest and also encrypted in transit. For companies migrating to the cloud, they often seek to improve their operational experience. They want more resiliency, they want more availability, they want more reliability for all of their IT assets. And that's something you can achieve in the cloud, especially with automation on the back end of that. But when it comes right down to it, businesses are really seeking ways to save money. And one guaranteed way to save money is to, well, reduce how much it costs to produce. A very simple way to increase profits. And by leveraging automation, reducing how many manual tasks we have to perform, and it also accelerates our productivity. All right, so when I worked in the data center as a system engineer, some of you guys that have actually worked at data center before, our solution to solve problems was just to buy your way out. We'd purchase more hardware if we needed more computer storage, would hire more engineers, or would spend weeks on some complex process that did nothing but create just a bunch of red tape and slow down innovation. But in the cloud, we have to shift our mindset and adopt a software-driven approach to how we manage our cloud infrastructures. So let's have a look at some of the main principles of DevOps. First is designing your cloud infrastructure to support constant change. As you move to to adopt more agile approaches in application development and deployment versus a typical waterfall method, applications are no longer updated once a year or even once a month. Most customers I'm working with update their applications quite frequently, daily or even hourly, if there are a lot of frequent changes. Also, we need to build repeatable components and not snowflakes. To support the need for frequent application updates, system components need to be built in a way that's repeatable and also consistent. Through the use of automation, we can achieve a very reliable cloud platform. And we must also anticipate for failure. So as you build your automation for the compute services or the storage services that your service rely on, we want to make sure that we're anticipating failure. The expectation from our users in 2022 and actually recent times as well is 100% uptime. And the last thing you want to do is lose your most valuable customer due to a reliability issue to your competitor. And the last point here is human effort and the security risk associated with that. The more human touch points you have in the process, the more risk you take on from a security perspective. We are imperfect beings after all, and it just takes one oversight to bring down an entire system. Maybe you didn't get your cup of coffee in the morning, maybe you didn't get your full 8 hours of sleep. And I've seen far too many times security groups and S3 buckets and NACLs that host sensitive data or protect sensitive data just be open to the world. All right. So the first thing I want to do is design for constant change. And as we design for constant change, we must prepare our new environmental builds. So this is your dev, your QA, your staging, your UAT and production environments. We must also prepare to apply frequent application updates to our infrastructure and changes to the infrastructure to accommodate changes in the business as well. So your infrastructure needs to be agile and flexible to accommodate those new business demands or changes that your customers would like to see or new product or feature releases. Preparing for instance failure or scaling to meet service demands presents its own set of challenges, as well as accelerating code deployment without compromising on security. So our main goal here is to maintain a known good security state without the need to involve security teams every step of the way anytime we perform application update. Now, I am a big fan of the GUI. I know we have some CLI warriors here, but I'm a big fan of the GUI. And the process for deploying resources, maybe one VM in AWS, is very easy using the GUI. But that process to deploy environments and resources at scale using the GUI, it's just impossible to manage. Imagine for a second, we're managing maybe a healthcare SaaS platform, right? And in this SaaS platform, they process terabytes of hospital patient data, and they're required to support multi-tenancy and single tenancy for their customers. Now, imagine deploying this infrastructure manually would take a significant amount of time, will slow down onboarding of new customers to a SaaS platform, and it would lead to a bunch of configuration drift between environments. And also becomes a maintenance and management nightmare. So it's at this point where we really start leaning into automation, right? We want to reduce the technical debt we incur as we manage these distributed systems across maybe multiple different regions, or it could even be across multiple different cloud environments. One way we can do this, one way we can kind of simplify the deployment is by using pre-built templates. We can rapidly deploy new environments, and by leveraging configuration management, maybe something like Puppet or Chef, we can bootstrap the operating system with pre-approved security configurations. So security is baked in from the beginning for terms of our services that we're offering, and we're shifting security closer to the left. Security is no longer an afterthought, it's built into our process. So let's look at a typical build process, piggybacking on what Felipe talked about earlier. In this example, we use CloudFormation to deploy the foundations of our infrastructure, where it deploys the VPC and launches the AMI. We can pass the user data on boot that installs Puppet to our instance. And once installed, our instance is able to pull down all of our OS configurations from the master. and that's the puppet master in this case. Similarly, what we covered in launching new environments, we can perform manual updates to distribute distributed systems to significantly. Well, let me pause and say that we don't want to perform manual updates to distributed systems, because that can actually increase our risk and is prone to human error. So if you need to perform a manual update, and if it's a frequent update or a frequent change, see if you can automate that change. Maybe use the infrastructure as code, or using some kind of automation tool to script those changes if you need to perform those changes at scale. So also for your engineers, no one really likes, fixing VMs, and our engineering time is actually very precious. So we want to make sure we're making good use of our engineering time and not having them to log into the portal and having to click around to make any changes to the environment. Lean into automation and apply those changes to groups of resources or to the entire infrastructure if needed to. Also, by describing our infrastructure as code, we're taking that software-driven approach, right? So no longer having to manually logging, as I mentioned earlier, no longer having to apply those changes and rollbacks, or just simple, just change a configuration variable, and updates can be applied to all the instances, as I mentioned earlier. So in response to instance failures within a system, the legacy approach involves sending a notification to an engineer. The engineer will then log into the instance, identify the root cause, and repair the root cause if it can be identified. Or if it can't be identified, then they'll just rebuild the instance. And of course, this is a manual process, and we're trying to move away from that. And this manual process increases our time to resolution and can significantly affect downtime. Rather, it's best to design for failure in the beginning. Use automation. We can fail over to multiple different availability groups if we needed to. We can trigger an automated rebuild of failed instances, and we can deploy most recent changes to that instance, leveraging automation to facilitate those changes. It's also important to test your environment frequently for resilience. We want to take a proactive approach to security, and that's exactly what Netflix has done by creating Chaos Monkey. Some of you might have heard of this gem of a tool before, and what Chaos Monkey does, it randomly terminates instances in your environment, and this can expose gaps affecting the reliability of your systems. For my developers, again, just piggybacking on what Felipe shared earlier, manually deploying code presents a higher risk of error and has the potential to bring down entire systems. There's also the challenge of managing conflicts between application packages and updates across a fleet of distributed systems. Now, through the use of a service like AWS Service Catalog, we can create pre-approved templates, and these templates are what you use to launch your infrastructure resources, that developers can self-service the deployment of that infrastructure. So no longer the developer has to put in like a ticket or a change request. You can, as a security professional and as a IT operations professional, provide these pre-approved templates that has all the security baked in, shifting that security model to the left. So developers can just self-service. So if they need the EC2 instance, no problem. We have a service catalog for that. Do you need a 3-tier web application? Do you need a Kubernetes cluster with security baked in? Sure, we have a template for that. And that's a really powerful use of the service catalog. So here's a high-level view of a deployment pipeline. Let me walk you through the components, right? So first we start with AWS Catalog to launch our pre-approved templates. And this is for Elastic Container Service. And then we commit our code changes to our version control system. And in this case, we're using GitLab. From there, Jenkins is used as a CI/CD tool to pull down, build, and push our container image to the repository. And then our ECS service, or Elastic Container Service, pulls down that container and places those, pulls down the image, and places those containers within that cluster. All right, so no one really likes having to fix a server, especially at 2 a.m. It's time consuming and expensive. So if you've ever been on call before, you know the pain of fixing something that's broken early in the morning when everybody's sleeping. So in the cloud, we take a different approach. Why fix a server when we can just replace it with a fresh build? And that idea has led to development of what we call an immutable infrastructure. And of course, that infrastructure or that architecture pattern, I should call it, has several benefits. For one, it can prevent configuration drift from a known good state. It also allows you to verify that the failure process works as intended. It allows IT teams to become familiar with the failure process so they're able to respond quickly to live events. But it does, however, require full automation of the instance boot process. So with an immutable infrastructure, you are not trying to apply changes to the current infrastructure. You're not trying to do updates to it. You're not trying to apply application patches to it. You're not trying to mutate that infrastructure in any way. So if you need to spin up changes or apply changes to the infrastructure, you're actually creating an entire new stack for those changes and doing a cutover to that new infrastructure. So one of the customers we worked with here at Logicworks, I'll give you this case study, is an enterprise class customer, and they host critical data for major 500, Fortune 500 companies. What they experience is what a lot of companies experience in the growing stage. They're growing rapidly, and unfortunately, they just overlooked a bunch of different security controls and reliability controls that place petabytes of their customer data at risk. They just didn't have the bandwidth to tackle everything that they needed. They were also rolling out a new application and wanted to test the viability of an immutable infrastructure. So what we're able to do at Logicworks for them is partner with them and codify their infrastructure. Everything was deployed through the portal with clicks. There was no infrastructure as code. They weren't using CloudFormation. They weren't using Terraform. And we're able to get into their infrastructure and codify everything. So now everything was described as code. And this helped us to automate the build of new instances. The environment could be torn down and rebuilt multiple times a day, and versus taking days or even weeks to plan and launch new services and new infrastructure, the team that we worked with for this enterprise customer was able to deploy new services within minutes. So now think of the return on investment. Think about the time you're saving in terms of innovating that allows you to outdevelop your competitors from days down to minutes in terms of launching those services. And in this model, the developers for this company were able, or rather I should say empowered, not able, they're empowered to self-service deployment of infrastructure using those pre-approved templates that I talked about earlier from the AWS Service Catalog. So operations team and security team worked on these templates, as well as a Logicworks team, to create and bake in security to the left. So as a developer, you no longer have to think about anything that's not business logic, right? So you can really focus at the task at hand and be creative and develop those differentiating features and services that drives your company to have that competitive edge. So all of these changes resulted in, for this company, a 0.001% instance failure rate and a near 100% uptime for their applications, and push button deployment to production with a single click for any instance configuration change that needed to happen. So overall, taking everything we've done for this company, it led to a 60% improvement in deployment efficiency. Massive, massive improvement here. All right, so let's talk about the impact of security and
Michael,
automation.
Paul?
Yes.
We've just got a few minutes left, so if you could go through this quickly, that would be great.
You got it, definitely. Just a few more slides here. I'll run through it fairly quickly. So on to the next one. So through the use of automation, as I mentioned, we can prevent human error by standardizing the build and update process and expressing those standards as code. The goal here is to have as little human interaction or intervention as possible with the environment. When we talk about patching, patching instances becomes almost trivial when you're using automation, and we're able to patch systems across different regions, across different availability zones, and across different services if needed. This provides consistency across your environment. And quickly, I'll just go through a couple more slides here, Ron. So in this example, we see a 3-tier application deployed across multiple AZs. Unfortunately, we have a security group that was misconfigured and exposes the application to the world. Now, for small environments, it's pretty easy to pick out, but what if your environment looks a bit like this and is scaled out? It could be hundreds of security groups, and they could each have their own set of rules for which traffic is allowed inbound. So the best way to kind of wrangle this is to use automation wherever possible. Using a combination of configuration management, AWS config, we can easily identify and remediate configuration drift. This slide just covers S3 encryption. We want to make sure you have a bucket policy for your S3 buckets, and in this case, we're using AES 256 as the filter for encryption. So any objects that are stored in that bucket need to be encrypted. All right, so in summary, as we talked about earlier, automation accelerates innovation. We can detect and recover from unexpected failures. And the great thing is that with automation, you don't have to start right now. A great step forward is really just ensuring that all your data is encrypted. So if you don't have the bandwidth to automate your infrastructure, or you don't know where to start, by all means, reach out to us here at Logicworks. We've worked on some amazing projects that enable companies to accelerate their growth. And we love to work with customers like yourself that are facing these cloud challenges. And that is the end. Thank you, everyone.